It's very dark outside, and I know in Asia it's most like it depends on where you are. It could be the evening or late afternoon. So we will continue today's training. So we do the same thing. We go through the PowerPoint slides, and this is a little bit different from what I usually do in face-to-face training, but this is just like the content combined with the lab practice and the GOP. Okay. So today we're going to talk about the extraction and analysis. The thing is, we have the samples now in the lab yesterday. Now the next step is the analysis. We had some questions saying how many days your sample must be extracted and something like that, which is just like when I use the word, I probably use word like storage time or holding days, holding time. I mentioned in my lab is typically about 1 year. So, but depends on the chemical, depends on a situation. Study director may give you a different opinion how soon it should be analyzed. For some studies, I know at least based on my experience, there's one study, the chemical is biphenazate. You have to do that within 7 days, and typically it's within first 3 days. That's because the chemical is called biphenazate. Let me write on the screen. Next time when you see this chemical, you know that it's biphenazate. Biphenazate. So this chemical is not very stable because it touches water. The half-life is about 14 days. So basically, if you because the field had sample, it's already touching the water. It's got the sample. It's already touching the water. The hydration degradation is going on. It won't stop, and even it's freezing, it's still working. It's still going there. So when you receive the sample, if it is about 10 or 14 days, because the half-life, T-half, it's roughly around 14 days. Roughly. It depends. Let's say put a 14D there. So if you analyze something, because at the very beginning, the reaction is like this. So first of several days, it's already like probably 20% off. So you have to analyze it as soon as possible. So this is the only one I know we have to analyze within a week. Otherwise, your work will not be good. But it's another good thing because you analyze it fast. You don't have to do the storage sample. So that's another good thing. It's not bad. But most case, the company, for example, Syngenta or Dow AgroScience, right now it's called Corteva. They probably will do a very broad storage test, and typically is 24 months. So basically, for most case, 24 months is the maximum you can wait before you do the sample analysis. Month. So most likely, this is most likely. So in every lab I go, we typically make it between it's about 1 month to like a half a year, so 6 months. So far the storage was not a problem. But it depends if your country may not be able to do it and you have to send your sample to another countries. That could be the issue because the shipping takes time. And sometimes is you have to keep a set of the sample just as a backup, and that backup may need to stay a little bit longer. That could be longer than a year, sometimes longer than 2 years. Okay. Well, we got quite a lot of people online now. Let's go ahead to today's training. So we do the same thing. We do a quick review, what we learned yesterday, what we focused on yesterday. So some of them is GOP required. Some of them is our lab practice. For example,
Hello,
we
Dr.
learned.
Wayne. Sorry to interrupt.
Yeah, go ahead.
A few people have trouble hearing your voice. Could you please try to adjust the microphone?
Is it okay now? Better?
I think so. Yeah. Yeah, I'll let you
Okay.
know if there are more comments on the sound. Thank you. Sorry.
Okay. Maybe it's a microphone. Let me see. I open my sound settings. My side is okay. You see, this is my speaker. This is my microphone. This is the microphone. Trouble. Manage sound. I don't see any issue here. I'm
We could
sorry.
hear your voice properly now. Thank you. Yeah.
Yeah, okay. I just need to be well, because it's too early. My son is still sleeping. I don't want to speak too loud. That's fine. I can say louder. Okay. So first we learned sample shipping here. So for example, if you hand deliver, you still have to freeze your sample. For example, if you your field site is a kilometer away, so it's not too far, and you can hand carry your sample, put in the a box, and send to the lab, which is allowed. But if you are not a part of the lab, you need to freeze your sample in your freezer, and you send the frozen samples to the lab. Okay, so in this case, the shipping sometimes even it depends. I was in some of those countries, the traffic even like within the city it takes like 2 hours. So that's a big issue there. So you do need to do that. So if you need to ship the sample, it depends on the situation. Typically, is you put in the box and you can ship that. And for example, if it is the what we call that the ACDS truck we have, which is the freezer truck, that's okay because they do have the required freezing truck to do the work, and they have enough resource to do so. But sometimes if you ship with dry ice, okay, then in this case, we do need to put enough dry ice there, and I put it at the ratio there, that's recommended ratio, which is 1 to 4. So 4 is the dry ice by weight. So the container should be a relatively durable. It's not just like a very thin paper, so at least a very strong cardboard box. I prefer the plastic, and also you need to do the temperature monitoring. So that's a big issue. So because if we keep talking temperature monitoring, it will take a little bit more work. Let me see. Did I do anything wrong here? No, it's okay. Okay, is it okay to hear? I'm sorry. Maybe sometimes I was talking to myself and you did not listen to me. Okay. I mean, you cannot listen sometimes because of the internet. Right now, the internet here should be okay. Everyone is still not working. Okay, the next we talk about a sample. We check the sample when the sample arrives in the laboratory. So what you need to do, you need to check against the protocol, check against the shipping documents, and you send the receipts to related party like the field people, QA, study director, and sometimes the management if the management is in different location. So all related people will get a copy of the receipt. That means the sample arrived to the lab safely. So you also need to have a unique lab ID. So in this case, from now on, you only work on the sample, this ID. So all the samples are treated equally the same. So we talk about the storage. So short-term storage, long-term storage here. So that's again, we have to do temperature monitoring. Okay, for example, do you have the alarm system? Do you have the emergency, for example, if something happens, emergency measure, okay? And what's the active, the corrective action? So if it goes wrong, okay, we talked about that. We spent a lot of time talking about grinding. Yes, dry ice is necessary. If you don't have the access to dry ice, you need to talk to study director and see and make the arrangement. What is the best way to handle this? Sometimes, if it depends on the sample, depends on the work, it may work with different ways. So, in order to keep the sample integrity, homogeneity, so a lot of things we do is we need to mix them, we need to keep them. That's a long story, but anyways, that's what we talked about. We talk about the standards here, which is here. We talk about the standards and the recertification for that standard. For example, we received some standard, then later we do it, and it's expired, but they don't send you again. They send you another piece of certificate. Okay, we talked a lot of requirement, which should be on the label. Okay, and we talked about the QA form. This one is a QA form, which is the in-life inspection. Okay, so we do the same. We do some let's say practice, or maybe we can do that later. Okay, but this is like a true or false. For example, we can do the first one. Oops, a copy should be a copy. Okay, a copy of original raw data or original data pages directly from the copier. So this is exact copy. So is this true or false? So what's the requirement in GLP for making copies? So in this case, we can say true or false. So what's the requirement? The requirement is in order to be used for GLP purposes, so everything should be verified by some people. So you should have, we call that signature or initial. I just put the initial there. It should be initialed, which you sign on that page, and date. Oops. Difficult to write, I'm sorry. So if it is not signed, it's not initialed by any people, so this is the false. So, well, we can keep doing that. That takes too long. But at the end of the presentation, we can go through these questions again. So I just quickly read those. Okay, so the next one, the number 2 here, is a computer printout derived from data, from computer media. I mean, to media from data sheet. So this is raw data. So anything you print from Excel, from the instrument, so that is raw data. So this is a true or false. Okay. So we should know that it's the same rule, same principle. The next one, the GLP studies may be done in some labs, in some facilities doing non-GLP work. It could be called a GMP work because GMP is manufacturing. Can you do it there? Can you do somewhere like a clinical or other labs? Can you do that in the ISO lab, not the GLP environment? Okay, so this is a good question. So you have to think about that. This is a good question. And we did talk about yesterday. So next question is about inspection. So normally any inspector or any people comes to a GLP lab, there's a lot of things there. You are not supposed to take anything away without any approval from the lab management. But this is the inspector. So the inspector can take photocopies, can take photographs. Is that okay or not? Okay, so that's true or false. The next question, okay, the raw data must signed by the second people. So not only one people, so this is true or false. And the data must be entered in the bound book. You know, older days when we do the work, it's always like something is bound, a book, rather than the loose pages like this. Okay, so that's the question. So is it a must or is it the option? Next question is about SOP. So we know that the lab people always send a copy, most recent version copy of SOP to QA. So QA must keep this. Is it true or false? And the study director needs to sign on the SOPs if there anything change. Okay. And the GOP requirement, for example, we have a lot of in there. We learned that the label, okay, this is a labeling. We learned that yesterday. We spent probably 3 or 4 times to keep talking about the contents. Okay, so is it all these are necessary or which one is correct? Because this one could be multiple choice, multiple correct answers. Okay, expiration date, identity, and it must be signed, and safety and storage condition. Okay. The next one is about who can be the study director or who the study director can be. Okay, for example, study director can be the archivist, can be the field research director, can be any chemist in the lab, can be the company CEO, which is the biggest boss of the company. It could be the lab management and QA. So it's the same thing, select all answers. Okay. Okay. Well, that's the quick review and the question. We spent about 10 minutes, 15 minutes going through, which that's good overview. So we are going to talk about the lab. So when we talk about the lab, the first thing is the detection limit. Okay. When you analyze something, you're going to report. You report your number. So this is the science term, LOD, LOQ. And this, well, that's the say that how you calculate that, how you get this number. This is science. This is not a GOP. Okay, GOP cannot regulate your LOD is this number, but GOP can regulate you should follow, or maybe your protocol can say, yeah, I need something like this. That's fine, but your analysis, the LOD is always there. LOQ is always there. You can set your level, but this is science. How you get that? So the science part for LOD is about your signal. This is your signal like that, and you have peak. Okay. So in this case, how can you identify this is the right peak, right thing for you, that instrument signal? This is your peak. So there's a lot of different turn. Of course, the turn is if it is reliable, if it detected from the background, or this is something, it's the noise. So science term, it did not give you detail, but the practice-wise, this is signal noise ratio greater than 3. So this signal ratio, the signal is up here. This is signal. And noise is probably the average from the background here. That's probably the noise or something. So this is the noise. Okay, so that ratio, if it is greater than 3, I know this is the right peak. Okay, so this is by science definition, but how you calculate that, because it depends. If you select this part as your noise, and it's different. If you select this part, it's different. So it depends on definition, but scientifically, this is the way. So because of this reason, the calculation will be totally different everywhere. Oops. Let me see. I cannot do that. I cannot undo, but that's okay. So scientifically, the calculations will be different. So LOQ now is something about the amount. The LOD is about the instrument detection, the sensitivity. So this one is how much you can quantify. Now, this one is typically for people to, LOQ is the amount. A lot of people say, okay, I add something to it, you give me the answer. But a lot of them is just simply, okay, I can do statistically a calculation. So in IR4 system, we do the calculation. Okay, this is calculated. And typically, this is 3 times of LOQ, typically is 3 times LOD, typically. It depends on the definition because scientifically it's different. Okay, so this is how we calculate that. So if you really look into statistical theory, that could be another 2 hours to keep talking about that. But in order to make it easier, IR4 and probably most EPA GOP system, we use a different term. We call that LLMV. Now, this is not science. This is a regulation. Why? Because we are talking about the method validation. We are talking about MV. Okay. So when we do that, that means I add 0.01 ppm concentration to the system. This is what I spiked in. So what kind of recovery is there? And this, if you calculate that, it's very close to or equivalent to LOQ, this LLMV. If you really calculate that, it's really close to, but it's different definition. So in a lot of case in the lab, and most people just say that this is LOQ. But that's different definition. LOQ is based on the science, based on the background. You get number. And LLMV is you added to it. So there's some argument there, but we use LOQ in our system. So if method here in this mitigation study, we use the LLMV here at 0.01 for most chemicals. Okay, so in this case, this LLMV has several things. We have the concentration we spiked in, and also we have the matrix information because it depends on the sample. And most likely LOD is instrumentation. It's not necessarily the matrix. It could be, it could not be. So if we have this now, then we need to think about, okay, so which kind of chemical that is. We talked about the same thing yesterday. Let's read this again. The reference substance, which in the lab, we typically call that standards. And in the IR4 protocol, it's very likely, and most of them should be similar, should be on the section 28. Okay, which is section 28 here. So they got a very specific terms for those things. So you need to get the GLP standards. If your standards are not the GLP, so I would say you need to talk to study director. Your work will not be acceptable. It depends on where your report submitted to, but I would say you need to put it on the stop sign there. Okay, so we talked about this a lot yesterday. We just keep going. Now we have standards. We have requirement, LLMV. The next is the method. So we do the GLP work. In general, we don't invent, we don't develop our method. We work on the method which is already there. You can, of course, you can do the method yourself, but it will take a little bit longer time and making longer to meet the requirement. That's complicated. So basically, in our work in the section 29 in IR4 protocol, we have the session called the reference method. So basically, somebody did this already. It's fully validated, and it has been proved that by other labs, other studies. So we know the full studies saying this is good. So you need to use this method and do the work. So that's typical thing we need to do. We don't regularly, we don't invent our method in our lab. So that's totally different area. Sometimes that's another GLP study. So in this case, okay, we have the method. But the method may not work in your lab. That's because they may work on different instrumentation. For example, this is the LC-MSMS. And you may not have LC-MS in your lab. Excuse me. Then you will say, oh, yeah, this doesn't work. Then you have to spend more time to work on this chemical. So another thing is depends on the matrix. If they say, okay, this is a crop, that means it's a lot of crop samples, but the matrix may be different crop. So the crop may be different. Okay, so in this case, it may or may not work. So you need to validate. Even it's the same crop, for example, mango. We did the mango study in Africa. That's like 6 countries, okay, from like Senegal, Ghana, Uganda, Kenya, Tanzania, and well, you name it, all those countries. The samples sent to different labs. I think 3 labs. One is in UK, one is in Ghana, one is in Kenya. So the 3 labs, each lab must do the validation themselves because you are different lab. You are not exactly the same as this lab. So you have to validate it. So we are talking about the method, validation, then we talk about the working method. So we are talking about the working method. And you see, we said a lot of times talking to study director. This is very important. This is a GLP requirement. So when we do the method of modification. We are changing the method because each lab is different. Okay, so you have to do that. So in this case, any change now, this is going to a very big question now. You can be a very small change, or it can be a very big change. So if it is a big change, it may not be good. If it is small change, that's okay because you are not the same as other labs. Of course, most likely the high levels are okay, but this is very difficult is the LLMV level. Okay, so here's the thing. When you talk to the study director, say, okay, I make the change. I talk to study director, this is the good results. The study director is saying, okay, the matrix interference is how much? Okay, then study director will say, okay, give me the working method. So this is the working method, a copy of a working method in my lab. For example, we put it there. We always call that working outline. But why? Because we put 1, 2, 3, 4, just a step by step. Because we do have the reference method there. We do not need to create a complete method. We just need to outline step 1, step 2, until you finish everything here. Of course, this is like a 5-6 pages here. That's okay. So at the very end of the working method, we put it there where the change is. Okay, this is the change. We change the column. The column is different. Their column is bigger, my column is smaller because it's more efficiency there. And also we change the mobile phase. This is good, this is big or small. And if you change a small portion, put in, for example, the percentage of formic acid from 0.05% to 0.1%, that is okay. That's small. But it totally changed from water methanol system to like a hexane system, then it's not working. So it depends. So we put a big question mark here. So we give this to the study director and just tell him, yes, we did that. This is working. The study director will go through that, read against the method, and say, oh, this is big, this is small. Okay. So the requirement for these working methods, which is the same as the SOP, because we put our method as the extension of SOP. So we have SOP book. The method is only the one part of that. So your SOPs keep adding because you have more and more method in your lab. Okay, so we follow exactly the same format as we have in the SOP. So we have all the requirements, the title, the method, abstract, and details, and page numbers, and the only our signatures and dates. And the only difference is we have to tell where the change is from the reference method. Okay, so we do that. Then the next is we're going to say, okay, is it minor? Is it small? This is because we changed the method there. Is it right? Or this is something called major. So if we define this as small, that's very simple because study director will approve that. But if it is major, that will be a big issue. So what is small and what is big? So here's something, this is science now, going back from the GOP, from protocol, from the regulations, from the requirement now to the science. So we go back to science, this is something. For example, if we change the sample size, if you do the extraction from 10 grams to 20 grams, that should be fine. Unless you go extreme case, you have, if the method says 10 grams, you go opposite way to 1 gram. Then that will be a problem because you may not have the sample integrity issue, the quality or homogeneity issue there. So that is not good. But if you think about it, you change from 5 grams to 10 grams, that's okay. Or from 20 grams to 10 grams, that's okay. Okay, so that is okay, but it shouldn't affect sample integrity or homogeneity. Okay, so in this case, that's called a mild. It's small. Or you change a small portion of extraction volume. Same thing, because you change this accordingly. Okay, if you use, let's say you use catchers, for 10 grams, you use 10 ml. 10 grams, you use 10 ml. The acetonitrile. But if you use 5 grams of sample now, of course, you change it to 5. Then that part is okay. Or you go opposite way, you use 10 to 5, 5 to 10. You change this to 10. Sometimes you go a little bit higher. Okay, you go 12 or you go down to 8. That's okay. A small part is fine. But I would say it's the same thing. You do not change things dramatically. It should be proportional. Okay, so that part is okay. Then the next is about the cleanup. So this is the tricky part now because the sample matrix is always the issue. So if you can modify the cleanup, it will save you a lot of time in the lab and make your lab efficiency. That's great. So you can that. You can totally eliminate a step of cleanup. But sometimes we add cleanup to the process because to make your life easier, because to make your instrument cleaner to do the work. So, for example, when you do Some work, you need to do the SPE cleanup. That's very typical nowadays. Sometimes SPE can remove a lot of different interferences like oil or something. But sometimes you go a different more step. You put like a like active charcoal to remove some color or some other thing, as long as your chemical is not affected. Or you probably add another step or DSPE, which is can do more removal from some interferences. Sometimes you add more. Yeah, sometimes you do two different type of SPE, which is different from the method. So that's good. Okay. And if your instrument is different, you always make the difference there, as long as you don't change significantly. For example, you change from the nature, then that is different. So that part, all those things are called minor. That's general thing. We call that minor. You talk to the study director, you will get approval. Okay, so you talk about sample size, good. We talk about cleanup, that's good. So what is the major one? Major one is totally different from these. For example, if you change the extraction. So yesterday, there was a discussion here saying, oh yeah, if I change the extraction, is it okay not? This is a big no, no, no. No, you cannot change any part of the extraction. Well, this is science as well as regulation. That's why, because we don't know. We are in the lab. We analyze the samples, but when they first develop the whole process, they use a lot of different terms to make sure this pesticide works this way. For example, one of the key points they do is to track the pesticides. If the pesticides, for example, let's use example, you understand why. And we always request to make the changes and always get rejection there. You have pesticides called that A. Okay? You put A in the crop B. Let's say B. And well, you spray that, and after a little bit time, you collect the sample to the lab, and you will have different fractions. Okay, you may have like leaves. Let's say we call that C. You may have the roots or some other part of a plant. You call that a D. And you have something going to the water, going to the soil. You call that E. So when you do the analysis, you will calculate, you will find, because you do the mass balancing, okay, you will figure that out. How much is A in C, in B, and in E, in D. And how much is there, how much is going, because the number could be going down because degradation is always going down. So you add everything together. It should be 100%. Okay, so in this way, you know this is exactly this chemical A going into your sample. Okay, now if you change some method, because they use different method here, maybe using shaking, grinding, and for something, then you know this is part of there. But if you change any step in between they have here now, you will get a different number. You never know. So that's why the company always say, no, 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 don't make this change. For example, if you use a grinder or a tissue miser or a high-speed blender to do the extraction in the method, and you want to use catchers to do that, the company always say no. That's why catchers, a lot of times in EPA method, they say no, you cannot do that. So you have to follow that. There's a regulation there you have to follow. So that's a big no. Okay, and something about the nature, about the chemistry. So if your analysis requires the derivatization, for example, GC, if you change the derivatization, and that's chemistry change. And that's the same thing. No, because the same reason you get all those steps, you change one of the steps, which is break the link between. So it doesn't work. So basically, that's the two major parts you have to think. These are all science related, not only necessarily this is the regulation or GLP. This is science. Okay, so basically science is they are saying they cannot make the change. Okay, happens all the time because we always want to have better recovery, and we always want to be more efficient in our labs. Okay, so let's do a quick question here. Actually, several questions. We just mentioned if we change the extraction from homogenization, like tissue-mizing high-speed blending, to catchers, is this good or this is not good? Most likely, this is not good, but talk to the study director. For example, in our work in the mitigation work now, we decided to use catchers, but some of the old method you have may not use that. So the quick answer is no. Okay, but talk to the study director. This may be a little bit different situation. They may have a newer, better instrument, the information there. For example, the company may have already done something. So you can talk to the company. Company may say, yeah, we verified the step. It was okay. Then that's fine. Okay. So, okay, I just want to do a little bit of housekeeping there. So for those who are just signed in a little bit late, please sign your name and email in the chat box. And in this case, we know you are here. We will give you the training certificate after tomorrow's sessions. Please do. Okay, so we know that this is a big no-no for this change. How about we make their change in the solvent? For example, if we change from acetonitrile to acetone or hexane. Oh, I already give you the answer now. This is big no. So the first step, that's the initial step, that's companies working in the background, we don't know. So you cannot change solvent. You cannot change extraction, very beginning. So those are the big no thing. Okay, so let's go a little bit more. So next one, is this big or not? If we change from a little bit cheaper instrumentation from GCMS to LCMS, is this okay? And that's a lot of argument there. Based on the science, the detector, this one or LCMSMS detector is equivalent or better. And well, it depends on what you think. So you only think this is only a tool to the separation. This is allowed. You have different separation, make it better. It's just like separation, just like a cleanup part. But if you are talking about the nature of the compound, because this need to be the gas phase. Okay, this is gas. You need to vaporize your chemical. And this is a liquid. You do not need to. So this is a liquid. Okay. So in this case, this is the nature. This is Mother Nature change. This is science change, chemistry change. So the answer is no. So it depends on where you talk. Okay. So that's a big question. Yes, somebody may argue, yes, it's okay. Somebody may argue, no, it's not. So it depends on the situation. Let's give this to study director and that a study director to decide that this is good or not good. Okay. The next one, well, this one is LCUV to LCMSMS. So this one is okay or not? And we do know, let's look this way, the HPLC is equivalent, it's the same. Okay. Now, if we only talk about the detection, this is fine. LCMS versus UV, that's fine. Okay. So if we talk about if there's any change, the UV is the wavelength of the double bonds versus you do the mass spec. So mass spec is getting more information out of there. So of course the LCMS is more expensive. So the answer is yes, you can do it. Oops, going on there. Okay. So yes, if you change from this instrumentation. So now we have very good idea what you can make the change in your lab. So if the method says using this, you probably don't have too many choices. So that's why, and very first day I say, I really prefer the LCMSMS because the method will, most the newer method will use that. But if you don't have that, we're going to have to work out in a different way. Depends on the lab situation. We need to talk to the study director. If, let's say, for example, if Michael Braveman is the study director, then we need to ask Michael, is this good or not? Okay, so we talk about something more. Well, it's a little bit late. Let's just go a little bit faster. So if you work in your lab, you need to verify every step. For example, this is one example. We could have much more than this. If you use the balance, okay, you weigh your sample here. Before you do that, you need to verify the balance. Okay, we use the standard weight here. For example, this is 300 grams. And if you read here, it is 300. And in my lab, in my experience, I never saw anything different. But I worked all over the world. Sometimes this is 1, sometimes this is 2, a little bit change in 1 or 2 digits there, which is acceptable because depends on your SOP, depends on a lot of them because the temperature may not be controlled well, or maybe humidity, or maybe use maybe it's the use is too much. The instrument is getting fluctuation, getting away from the real number, and in this case, that's okay. But as long as it's within your SOP range, typically it's just like a 1 over 10,000. That should be okay in the lab for analytical balance. So you need to verify that, and you also verify you need to cover the range. So if your sample you weigh your sample here, okay, you weigh something let's say you weigh 10.01 gram. This is the one. So you need to cover this range. So this is gram. So your range, your verification range should be the highest weight for everything. Here, for example, this is 200 grams, including sample, including the bottle. So it's 200 grams. And you go, the lowest is about 1 gram here. So you need to verify down to 0.01 gram in your lab. Okay, so in this case, you probably want to have number in between, which is around the 10 grams. So you probably want that because that's the most important number you want to verify. So you use all those standards in this range to do the work. So you say, okay, this is good. My balance is good. I verify that it's good. You need to document that. You need to put everything in your raw data, which we will see in a few minutes. Okay. So now let's erase something. So we have this now. And of course, it's always a good idea to put something to protect the balance. I put a piece of weighing paper down there. Okay, sometimes you will get some kind of a condensation if you weigh the wet sample or cold sample, and you will see this is my work. I did myself. I always do two labels. One is the label. One is directly write something on the bottle. So it's not a requirement, but it's good practice because this kind of label sometimes can be peeled off. And sometimes the label on the bottle, sometimes you have solvent drop on there, it's difficult to read. So if you lose both of them, the identity, it's not so likely to happen, but this is what I do. It's not a requirement, it's good practice. Okay, now you put the samples there. So sample, okay, you put the samples there. The sample is frozen, so don't let it thaw. Don't wait to room temperature. And you will see there's a little bit, because it's cold, a little bit of condensation there. You see the water there, condensation there a little bit, which is on the surface there. That's okay. Do it immediately. Don't wait. I know the reading, for example, the reading here will change. This reading will change. If you leave there, now we weigh exactly 10.00 gram. That's exactly. You do not have to weigh exactly. But this number, if you wait there for like 1 or 2 or 3 minutes, because of the humidity, you will add another 0.01 or 0.02 there. This is likely to happen, and this is okay because it depends on where you are. If your working condition is very humid, you will see big change. And in the wintertime in Michigan, it's very dry. We leave there probably 1 minute, we don't see any change because it's very dry. Outside is negative 20 degrees. Inside is a plus 20 degrees. So there's very little humidity there. But you do the fast. Wait in while it's frozen. Frozen sample. So while it's frozen. Don't let it thaw. Don't let it wait. Don't wait. So the accuracy, because if you weigh 10 grams, your accuracy, even the number will change in this way. So your error, the weigh-in error here will be what? So the error is probably, if we talk about science error, it's not a human error. So it's probably plus or minus 0.01 or 2%. Or something. No, sorry, 0. That's 0.1. Yeah. So in this case, it won't affect your results at all. So just go ahead, do quick job. So let's look like what Michael said. Oh, show the balance log, show your work, and I will show you my work. Okay, this is my work. This is, for example, before you do that, you know exactly what you want to do, so you can print this page out. Okay, so you know the date you're going to do the work, and you're gonna check the balance. This range, I know I'm going to weight something 0.1. 1 gram should be good enough because if I weigh 10 grams, so and it will I typically verify 0.1, the lowest one. That's fine. So it will, even this error, that will be like 1% error. That's fine. So, and this is the range. At least I know I'm going to weigh 10 grams here. So I'm going to verify that. Okay. And this is the, for example, let's read the balance log. This is a similar thing you need to put in there. And this is balance log. This goes, the original one goes with the facility. That means you will not have this balance log in your package. So your data package will have a copy of this. You will make a copy. And you will stamp that as we just talked about that. This is called a true copy or exact copy. We will do that. So because the original logbook should go with the balance. Because balance is part of the lab. It's not a balance, part of your study. So you only keep a true copy to your data package. So what we need here, let's read this one by one, and this why this is important. We know that. Okay, so we need to know date and time, who did the work. You can say This is on this date, this person did this work. And this is, you did certain thing about the balance. You have a little bit of calibration because the balance itself has auto cal. Okay, you can do that, and that will give you the certain range because it's built in. This is already a calibration for balance. Of course, you do have a balance calibration, like annual calibration balance there. So that's one thing. It's good. The balance is good. There's nothing wrong. Then you're going to say, okay, how heavy your bottle is. Remember we were doing the bottle thing? So how heavy this bottle is. You don't want to go over. If this bottle is 500 grams, then you need to have something 500 grams here. If the bottle is only 50 grams, for example, if it's 50 grams, you need to write this down, plus your sample 10 grams. So you need to get something at least more than 100. So to cover the range. And this is good range, good practice to cover all the range you need. So both the glassware won't be greater than 300 grams. So that's good enough. Then you put the number there. Okay, you put it there. That will be 300. You read from the balance. And it will be 30, 50, 25. Then the last one will be 1. So you will read all these things. And this is necessary. Make sure you get this right. However, this is one thing. If the balance was used by someone today, you do not have to do this. But how can you get the data? For example, if Michael is doing that work in the morning, 10 o'clock, then I do this, the work using the same balance 1 o'clock p.m. I do not have to do this because Michael did this already. So the balance is good. I know that. It's not just like a week ago, okay, Michael did the work. So, however, where you get the data, that's the question. Yes, you do not have to save your time. Lab is more efficient. So how you get the data there? Okay, so you need to make the copy of Michael's work, put it in my work. Then that's fine. Now, it's getting complicated. If I were you, I would not like this. I just do myself. Okay, I know by theory, by science, you are right. But GOP, you are right. You do not have to. But I just do it. Okay, I will do it. This is what I think. Because also you already planned, you printed this form there. So it's better I do myself. It just wastes another probably 2 minutes. It saves a lot of question because QA will ask, did you verify that? Are you sure this is right? No. So I do myself. I always do myself. It's just, okay, just put it on there. 2 minutes, you write everything down. Okay. So we did that. So the next step is you weigh your sample. So this is your sample ID. Okay, you have the sample ID here, which is here. This is the ID. This is the PR number. This is sample ID. So in our lab, it depends on which work you do. We always have different ID there. Okay, so you have, because remember this J1, J2, J3, J4 here is the identifier I have here. So it's easier for me directly. Otherwise, you have to write all those things. That's too long and too easy to make mistakes. So I've made a J1, J2, J3, J4, J5. And this is your sample ID. This is a control. And this is the QC spike, 2 treated samples here. And this is called one set. Or sometimes you call that one batch. That's okay. Okay, so in this case, that's it. Then you put it down there. How many? Okay, this I weighed 10.1 gram for this control, 10.00 for this spike sample, 10.02 is for next one, 10.00 is for this one, This one is 9.99. If you need to have any question or observation, you write it down there. Otherwise, this is blank. This is just for your information. Okay? Then you finish everything up down to here. So this is necessary. This is important. This is real data. Well, you do have different data in your work, but this is what I do. Okay? And you also need to verify the pipettes. Nowadays, it's most likely is the micropipette in the lab. So you need to verify that. Typically, I use water. So because I'm going to spike 0.5 gram or 0.2 gram, the volume. So those are the ones you need to verify. Typically, because this one, the biggest size is 1, I always do 1. And this one, typically, biggest size is 0.2, I always do this. And you're going to spike the lower one. Okay, so that's the one, so you have all the information. Okay, of course, let's just remove those, erase those, and let's just go through the other thing we need to know. So we need to know the ID or those, this is the GOP requirement and plus our lab. Okay, so we have this observation, check balance, we have the vessel, we have this is a sample, this is a jar, and we have this minimum requirement. It must be 1 control and must be at least 1 spike sample. That's the requirement, protocol requirement. And then you do all your treated samples there. Okay, and you have to verify your micropipette for the spiking and for other work. Sometimes when you do the SPE, DSPE, sometimes this is necessary. So we talk about spike. This is the spike. You can use all kinds of analytical tools to do the work. Most labs use this kind of a micropipette because this is a mechanical piston going inside. You will have to verify at least every day. So I do that every time before I use it. Okay. So sometimes some people may use this already. You do not have to calibrate or verify it. Same thing as the balance. But the thing is, do you have data to show in your work? Because Michael did that. I need to copy his work to my data, which takes more effort. So I do myself anyways. So I do that, which I show here. I did that. Okay. So this one, and you can use airtight syringe. So in this case, because this is a piston as well here, so you still have to verify, even though it's small. How you verify, it's very difficult because the volume is small. So it's difficult. It depends, and that's why most the spike is this one. And another one is use glass pipette. That's the best one because if you don't break the glass, you don't change the glass, for example, you don't put it in the oven to dry, it's fine. Okay, so in this case, the glass won't change. And as long as you use verified, typically what we call that class A, then it's verified this for this level. It's the error is typically 0.0. I think this one is 0.01%. It depends. If you have 10 ml1, and this is probably 0.01%. It depends the volume. Okay, there's a question there. Could you please send me the PowerPoint file? Yes, I will. I mentioned day 1. I intentionally put it on hold. Of course, I will add. Sometimes Michael said, add something there. I will add one more slide. But I want you to listen what I say. Then after this presentation, I will have put it on a server. You can download it there. If I cannot, well, IR4 has that. If it is not easy, I will email you everything. Just wait. I want you just Just look what I need to tell you. Okay, this is the purpose, just like you go to class. I want you to listen to the teacher, to the professor, how he's teaching. Okay, then if you only read that, you can solve this, then I don't need to be here. Okay, so I intentionally made the delay to send to you. I sent a copy to Michael already. So just wait. Just listen to what I say. Yeah. And because you have question, you can ask question in the chat box immediately. I can answer immediately. Okay, then we do the method validation. Well, this part is much easier now. We have all the tools there. Okay, the requirement is all the method validation must be in triplicate, and the protocol will give you the levels you need to do, and that should be for both parent and metabolites. So you can spike then 2 spikes, or you mix them one spike. So it depends on how you do the work. Okay, and also sometimes they are different chemicals. You may have to do different extraction. Then you have to do, anyways, you have to separate. So the key part here, requirement. One mistake, because when you do triplicate, if something is like a recovery is 69 for one of them, and if somebody reject your work, that means the whole thing is wrong. You cannot use, for example, you use the level, lowest level, you have sample A, sample B, and sample C. You get a 69, this one. You got a 70, this one. You got a 71, this one. And this one, you have to talk to study director to get approval. And the other 2, you do not have to. However, because this is in triplicate, this is one thing. So if 69 is not good, none of them is good. So you cannot just pick up, oh yeah, I like this, I take this one. No. So you have to get the triplicate. Triplicate is just like one set of sample. Okay. So we made one mistake a long time ago. We were trying to collect all the data to calculate the LOD, LOQ, and that was a big argument with QA, with other people. Scientifically, you are fine, but because they say this is triplicate, that means triplicate as one sample. Then one is no good, out of range. Everything is out of range, no good. And well, we have one result. One set of result here. Most important thing is on the top is talk to the study director. Your data are good or not good. Okay, and it depends how you do the work. If you do the work, you do not have to put the control there because we know control is low. Okay. And if you put a control there as a comparison, good. So this is one thing. And of course, we do know the range should be here. It depends on your application, depends on where you submit the data to EPA. Typically use this one, and I know almost everywhere use this one. But some places use 80, 100, 120, but depends on that. Then follow whichever is more restrict. Okay. This is a typical EPA one. Oh, I do have a question on there. I have some experiment just with duplicate. Is that acceptable? The quick answer is no. It's not acceptable. Okay. EPA will reject the data. Most likely JMPR will reject your data. And our protocol, I'm sure Michael is going to use the IR4 protocol as the template. So a protocol requires the triplicate here. So in this work, mitigation work, it must be triplicate. If your government or your agency accept the duplicate, that's fine. That part of work is okay. This work must be triplicate. Okay. Okay. Here's another question. Okay. We talk about a GLP or GLP clock. I would say GLP clock. Let's say it's a little bit easier because you need click the clock to start, like a stopwatch, to start your GOP in your laboratory. So if the field is working on something, the lab is not doing anything. I don't have to do any GOP because I don't have anything. Is that right? So when it says like that, GOP starts in the lab. Okay, we put some answers there. Of course, when SD signs the protocol, the whole study starts, not the lab only. Okay, the whole study, everything is starting. But lab, I don't have sample, I don't have standards, I don't have method, I cannot do anything GOP. So in this part, I don't have to do GOP, which is correct. So the first one, that's not a correct answer. Okay, and the second one is you receive the standard. And you have if the field already did application, that means yes, it's already started. So what is put the first application? The GOP, the EPA GOP, there's a special term called that experimental start date. Let's say experiment start date. So that one is this one. So when your substance added to the system. So experiment started already. So that's by the definition. But this is the field. You know, a lot of people, you know that. Field and lab, I are full, field is field, the lab is lab. We are separated. We are not the same people. Okay? So, no, the lab is not started here. We don't do GOP because we don't know anything. So when the first sample arrived at lab, now I have the sample now. I have the sample. I have the standard. Is it GOP started? Yes, GOP started. However, we still say this is a no because I don't have a method. How can I do GOP work? I need a method. So in this case, I put a question mark there because by GOP, this is started. But the reality is we are not. Okay, let's just remove that. It's too many. Okay. So let's do that. Okay. So I put 2 there. One is wrong. No, it's not started. One is question mark. By GOP, this should be started. By GOP is first one. When SD signs this, by GOP, this is already started GOP in the whole system. But my system is very end. So the correct answer should be the last one. Okay, I have standards in my lab. I have samples in my lab. I have method done. I did method validation. And the most important part, I got study director's approval. So when we talk about GOP, if anything related to study director, and that it should be most likely should be the correct answer. Because the study director is single point of control. So here's the question now. Okay, between somewhere, let's say somewhere here, put a question mark there, and we do the method validation, this area. How we handle the GLP? Yes, by theory, it is GLP. How we handle that? Okay, EPA call that, this is called exempt because there's a lot of method development there, exempt. But it is GOP. So it is GOP. So what you need to do is you keep all the data, but separate from your study file. You do need to keep them. Okay, it is GOP, but they don't want to see that because so many failed trials. Okay, you try the first one, it didn't work. You try second time, didn't work, and you may spend probably 2 months to work on the method, and finally you got method ready. So in the lab, what you need to think about is the most important part is the study director. Forget about this. You keep them, put it on the side. Okay, forget about all these. These are no good. These are no good. Forget about these because it's not practical. The practical part is the last part. When you finish your method validation, I did my method, I got good, I got good recovery. And the study director said, you are good. So that is the lab. Okay, let's just move a little bit more. Okay, we got that. Then we do the sample. Oops, we do the sample analysis. This is a big thing talking. So there are some other things we need to say here, which what is your analysis? For example, what is your R squared value? I thought it should be here, requirement. Let's just go through this quickly. So we follow the method. The method should tell you how to do that. Okay, then you have the working method. Then to always talk to the study director, talk to the study director, talk to the study director. So anything you did good, you did bad, talk to the study director. Okay. So and also when you finish your run, it should be, we call that set. Remember I mentioned that a set, it should be, if it is a validation, it should be in triplicate. If it is a treated sample, it should be minimum one control, one QC spike, and the treated samples. So it must be that. Then it's called a set. Okay, the definition here. Okay, then you put all those there. Then you put, okay, this is good or not. We have the criteria to say your run is good or not. So what is the set? Okay, the set is like this. As we wait in the balance. Okay, minimum requirement is you need to have at least one control. Sometimes, some places, it depends on how you say. They say solvent blank or matrix blank or something. Then you have more than that. But solvent blank is not that important because the whole system must be clean. Otherwise, it won't work. Yes, by science it is important, but by GOP, by our residue study, the control is more important than solvent blank. Then you must have at least one spike, and that spike should be very close to your residue samples. And the rest of them is the residue samples. Well, here's the question now. How do I know the residue? We don't know. So in this case, you have to use your scientific judgment, how you do it. Okay. And here's another question now. Different requirements are here. Some places, they always require you must have the lowest LLMV in there. For example, I think that's EU requirements. So when you do your analysis, it must always have the lowest spike. But EPA requirement is you should have similar to the spike level to your treated samples because that's more realistically reflect your sample. Okay, we don't know. We don't know what's really going on in the treated sample. If we do know, we don't need to do our work, but you use your scientific judgment to do that. So in EPA work, most likely you can spike almost everything, as long as you have good common sense, scientific sense for this level. In our work, we make it bigger. Okay, this one. This is zoom in here. Okay, so in our work, we put the big name there right in the middle. We put the spike level. So it's easy for us to track what's going on. So this spike level is LLMV level, 0.01. And another one is, we believe the residue is around 0.1. So we spike that. So in the EPA, GOP EPA work, basically you can pick up any spike you want. Okay, but I think in EU you must spike the lower one. Even in Canada, unless you have a reason, you must do this one as well. So it depends on where you follow. Okay, it's not necessarily GLP, it's the country requirement, it's the registration requirement. Sometimes it's your residue driven. So if residue is low, you always need to have someone. Okay. So that's called a set. So that's the definition, a set. Okay. So let's move on. Well, it's already 7:30. Maybe let's just pause here. Maybe another 10 minutes. Next 10 minutes, let's do a quick coffee break. I know it's later in Asia, so let's do that. Then we will continue our training. So it's 7:26 New York time morning. So let's say 7:35, 9 minutes, we come back. Okay, let's have a coffee break. Do you have a question there in the chat box? Okay. Well, let's have